Hello everyone, I am Kavin Kumar. Today I am going to take a presentation on mechanisms and robot kinematics. Planar mechanism. Planar mechanism is a 2D mechanism which has 2 degrees of freedom. Uh, in planar mechanisms, there are two types. Mechanism with a low degree of complexity and mechanism with a high degree of complexity. In a mechanism with low degree of complexity, it has one higher order floating link and only one point of it is unknown. In high degree of complexity, two or more floating links are present. Uh, my planar mechanism is designed with the help of MATLAB. MATLAB is a coding software which can do multiple engineering topics. In MATLAB, our kinematics is designed using Simscape module. This is the block diagram of the module which I am designing. This is the complex mechanism I designed using MATLAB. First of all, we have to introduce a machine environment to run a overall linkages. Then we have to assign a body for the number of links we have to assign, and we have to assign a ground for the picture of the linkages, and we have to provide a revolute pair in order to provide movements for the links. Here in my mechanisms, totally 5 bodies are provided. Revolute pairs are provided in between ground and body. The joint sensors are introduced wherever we have to measure velocity, acceleration of the linkages. In order to take output from the joint sensor, we have to introduce this scope option, which shows the results of our velocity and acceleration purposes. Uh, in ternary link, uh, the body have to have three ports. We can assign a number of ports using add option in the MATLAB. After joining all the linkages, uh, we have to simulate this using the play button. This is the simulation of my mechanism, and the different graphs like acceleration, the different graphs like angular velocity, angular acceleration, computed torque, and reaction force can be obtained using this joint sensor. Uh, After completing the whole setup, we have to choose which parameter we have to measure. Then we click and apply. Then we have to run the module, and with the help of this scope option, we have obtained a graph like this. This is my mechanism that I designed using MATLAB software. These are the velocity analysis of the points. This is point A, point B, point C, and point T respectively. The graph shows the peak shows that these are the velocities at the these extreme points of the linkages. Uh, Here in my diagram, this is point A, point B, point C, and point D respectively. This is the acceleration diagram showing different acceleration at the points. Next, synthesis of mechanisms. In synthesis of mechanisms, there are three types. function generation, motion generation, and path generation. I chosen a function generation. I done the function generation with the help of a GAM software. With the help of this software, we can do function generation, motion generation, and path generation. We can also design a 2D mechanisms, and we are able to simulate it. First we have to choose a synthesis, then we have to go for a mode and provide a function generation option. This is the input parameters. Here the length of the links are fixed. In function generation, alpha, theta, and pi values are given. We have to assign the link lengths according to our assumption. Here in function generation, the theta values can be assigned by us. Here for the value of theta 1 and theta 2, 45 and 30, we acquire this configuration. For the values of 60s and 60, 75 and 90, we acquire the corresponding configurations. These are the cognate linkages. Cognate linkages are the linkages in which the input and outputs of the mechanisms are similar. It also have the same coupler curve, but the dimensions of the cognate linkages are different from our desired linkages. Next, dynamic force analysis. In dynamic force analysis, I am using the software Mechanalyzer. Mechanalyzer consists of a static force analysis. For dynamic force analysis, we have to convert our parameters into a static force analysis and manually solve it. Then we have to assign the values in the respective parameters. I chosen a slider crank mechanism for a dynamic force analysis. The input parameters link L1 and L2 are provided. I also provided a offset between a ground and the slider axis. The link for is already automatically configured by the software itself. Theta 2 is the angle of the crank that you have to assign. The magnitude of force 2 Newton is assigned on the link L1, and the force on the force 1.4 is assigned on the link L2, and force on the slider is taken as 1 Newton. These are the corresponding free body diagram of our slider crank mechanism. And these are the results obtained after solving the mechanism. The torque on the L1 due to the force F1 is 51.96. Torque on L1 due to F2 is minus 36.01. The torque on L1 due to F3 is 11.93. Net torque on the L1 is 27.88 respectively. Next is serial manipulator. Serial manipulator is basically a robo which can be programmed. I chosen a 7R manipulator which consists of 7 revolute pairs. 7 revolute pairs. It is a serial type of robot kinematic arm which helps in pick and place the object. Here, manipulator in space, we transform coordinates from body fixed coordinate with respect to a ground fixed coordinate. The various positions of the 7R mechanisms are shown below. These are the different positions of the serial manipulator and the H ocean. And this is the DH parameter for our 7R manipulator. Thank you.